Hey everybody, it's Miss Fonstock. I just wanted to do a quick video with you guys about triangles. Something I want you to know before I get started is that triangles is actually a 7th grade standard. So for majority of this video, I'm going to be doing a review of triangles that hopefully you remember. Some of the stuff is even like 5th and 6th grade information. And then at the very end, I will introduce our 8th grade topic. All right, you guys, so the very first thing we need to talk about is just some basic vocab. This should take us, absolutely no time. When you're looking at the angles of the triangle, remember we're talking about the inside angles, just like my little mouse is moving right there. If they're all 3 acute, then you literally name that triangle acute. Remember, acute is anything under 90 degrees. If you have one that's obtuse, so that would be a very large angle in one of the 3 corners, that would be called an obtuse triangle. And then the last one is a right triangle. Remember, a right triangle is marked with a box in the corner, and that would be anything that is 90 degrees. All right, so triangles that are with no congruent sides, meaning all 3 sides. We're talking about the outside of the triangle now, the outside. If no 3 sides are alike, we call that scalene. If 2 of the sides, like this one and this one, if they're both the same on the outside, but this third one is different, then we can call that isosceles. And then when all 3 are equal, we call that equilateral. Again, this is just a quick review over some basic vocab. All right, something that you should have learned last year, and if you had Dr. Anderson, I know that you did. So if you had 3 angles on the inside of a triangle, 65, 60, and 55, and all 3 of those angles are different, they're always, it doesn't matter what numbers you put in here, they should always equal 180 degrees. That's our magic number that Miss Cooper and I actually referred to it as our magic number. So I'm going to highlight this. 180 degrees is our magic number. And again, it's when you add up all 3 angles of a triangle. And guys, we're letting you use your Decimus calculator, so please make sure, please, that you're, adding correctly, because you should always get 180 degrees if it is a triangle. All right, so let's go real quickly. We've got a bunch of different angles listed here, and then on your sheet, if you want to just take a second, pause the video and fill in these angles. We're going to go over some, again, just kind of basic vocabulary. And if I can get this pen to stop working, that would be great. Okay, so inside angles are what we call interior angles. So because these are the inside of the triangle, we call those interior angles. And then anything listed on the outside of a triangle, that is what we call exterior angles. And those words I think should be familiar for some of you guys. Interior, again, meaning inside, and exterior meaning outside. So this is a little bit more 7th, 8th grade-ish. We did do a little bit with exterior angles last year. We will do a lot with exterior angles this year. All right, so let's move on. Something I need you to notice is that if you have an interior angle plus an exterior angle, they're actually going to equal 180 degrees together. And I'm going to try my best to kind of draw something real quickly. So if I've got a triangle, it's not very pretty. Sorry about that, you guys. And I've just got this like random exterior angle hanging out over here. Okay? If I have this angle, which we would call the exterior angle, if I add it to the inside of this triangle, which is the interior triangle, let me use my finger. That might work a little better than my stylus today. But if I add these 2 up, they're going to equal 180 degrees, which is kind of cool because again, that talks about our magic number. So all three of the inside angles equal 180. Plus, if you take one of your insides and add it to the one outside that's kind of sitting right next to it, that's also going to equal 180 degrees. So that magic number is going to keep popping up. Something I also want you to take note of is we learned about straight lines last year in 9th grade or in 7th grade. And this is a straight line. And straight lines also equal 180. So that magic number kind of pops up in more than one place, but it's always going to pop up when we're talking about our angles. All right, so this is just some, real basic practice. We're going to run through it rather quickly. You can, make sure you have your calculator pulled up either on Desmos or even your phone calculator is fine with me for this. There's no fancy numbers you're going to have to type in. So if we take our three angles, we've got 51, we've got this box, which if you remember, that box is a 90-degree angle. We talked about that earlier. That's going to be 90 degrees. And then x, and we don't know what x is. Anytime we see x, we know that that's our unknown. And we're going to figure out that it's 39 degrees, you guys. The reason why we're going to figure out that it's 39 degrees is just simple math. So again, we're going to take 51 and we're going to add it to 90. And we don't know that the third one is 39, but we do know that they should equal 180 degrees together. So there's two ways you can do this. You can go ahead and add these two and then work backwards, subtract. So that would be 141. So you would take 141 and subtract it from 180 and you would get 39. Some people though like to start with 180 in their calculator and they like to work backwards the entire time. So instead of adding anything up, they just start with subtraction and they'll take away 51 and then they'll take away 90 in their calculator and they'll just subtract the entire time. But no matter what method you choose, and I'm sorry that got a little messy, but whatever method you choose, you're always going to get the right answer as long as you're using 180 as that magic number that they equal. Okay, so the next one, and if you're paying attention, I accidentally let it pop up. But this time we have two unknowns. And it's an isosceles triangle. And from our other vocabulary section, you know that isosceles triangle, it has two sides that are the same, this one and this one, which means it also has two angles that are the exact same. So this one's a little bit trickier. We did do this for a minute in 7th grade. So let's see if anyone knows how to solve it. So we know we have 66, and we know that we have two empty spots, and they're calling them x, so I can call them x as well. And we know if we add up all three angles, it should equal our magic number 180. So again, there's two ways you can do this. You can say 180, and you can take away your 66, and you can say, okay, well that's easy. 180, and I'm actually pulling up my calculator right now, minus 66 is 114. But guys, if you remember anything about angles, 114, that's a really big angle. That's what we call obtuse. And these are tiny little acute angles. And plus, I was supposed to fill two spots, not one spot. So because these two sides are the same and these two angles are the same, I need to cut this 114 in half because I've got two angles. So now I'm just going to take my calculator and I'm going to divide it by 2. And that would give me 57. Okay, so let me show that as your answer so you can see it. It's 57, and again, it's 57 for both. We cut it in half. There's also another way you can do it, which would be a two-step equation. And some people like this method, so I think it's kind of worth showing. I'm going to set it up like an equation real quickly. I know I have two x's. They're right here. And I know I have 66 already. And I know it should equal 180. So if you remember anything about our equations from 7th grade, you're going to minus the 66 first. Bring down the 2x because you haven't used it yet. And that'll give you that same number we had before, which was 114. And the only way to get rid of the 2 that's attached to the x is divide it, which is what we ended up doing. We ended up dividing by 2, and you get 57. And that's x equals 57. So that means this x is 57 and this x is 57. So either method will get you to the right answer. And let's go ahead and move on to our next one. All right, so this is, I already gave you actually an example of this earlier. This is our exterior angles. So I said that interior angles, which are those inside angles, this one, and this one, they equal 180. But we also said that because this is on a straight line, right here's a straight line, that this 48 plus this exterior angle would also equal 180. So what plus 48, we can call that x. What plus 48 equals 180? Well, guys, that's just simple subtraction. What is 180 minus 48? And I hope that you guys all said 132. It is 132. And guys, that makes sense. This is a very large, obtuse looking angle. And 132 is a very large, obtuse number for an angle measurement. All right, for number 4, I know this looks very similar. The picture, is the exact same. The 48 is now over here and the 84 is over there. So what I need you guys to know is that this is where it starts to get really 8th grade-ish. And then there's a vocabulary word that I would like for you to write down or type onto here. The theorem that this is actually called, it sounds very scientific, but it is called there we go. It is called the it's not letting me write, you guys. I'm so sorry about that. It's called the exterior angle. And remember, it's not angel, but angle theorem. My handwriting got a little bad, so sorry about that. Oh, and I misspelled it. That's supposed to be an O-R-E-M, theorem. So exterior angle theorem. So first off, a theorem is just a theory. But in this case, like it is proven. Angles, we're talking about triangles. We're talking about their angles, so we're good on that. And then exterior. So we're talking about how can we figure out what this exterior angle is. And this exterior angle is right here. Remember, exterior means the outside of the triangle. So what does that exterior angle equal? Well, if you remember from the one we did before, you already figured it out. But there's a new way to figure it out that I need for you guys to kind of hone in on for a second and look at. What I need for you guys to know is that when you have two angles given to you, this one and this one, they're far away from this exterior angle. And so they are what we call remote. And I'll kind of draw the best I can, like a little diagram. They're the remote interior angles because they're on the inside. And the way I like to remember this, and Miss Cooper always gives this example, is that you use the remote to change channels because the TV is far away. So when we're talking about something that is remote, we're talking about something that is far away. These two angles are far away from this exterior angle. So in order for us to figure out what this exterior angle is, because that's what it asked us to do, find the exterior angle, there's actually two ways to solve this. There would be the very 7th grade approach, and it would be, okay, well, I've got two numbers on the inside of a triangle, but I'm, missing the third one right here. I'm missing this third one. So I would just take 180 minus the 48 minus the 84. But again, if you want to add these two first and then subtract from 180, you can. And in this case, guys, you actually get 48, okay? You get 48 again. So I know that I have all three angles of a triangle. And then you could tell yourself, well, now that I have that, I know that this is on a straight line and I can subtract from 180 again. So 180 minus the 48, and that would give me the 132 out here that I already knew I had. But guys, there's actually a shortcut. And this is what would be, I would consider the 8th grade approach to this. So I'm going to erase all of the stuff that I have, and I want you guys to see something. The remote two angles on the inside of the triangle, they're actually equal to the exterior angle if you add them up. So if you add 84 and 48 together, you have your answer, because 84 plus 48, that is 132. So by adding the remote interior angles of the triangle, that gives you that quick step to figure out what the exterior angle is. You don't even have to figure out this inside angle right here. You could, if you forget this, you could, start with the inside, figure out all three insides, and then subtract. But to me, this is just the quickest way to do it. We will do some more examples like this in our lesson. We will also do some more examples of angles with algebra and how that looks in our Zoom session. But I hope you guys enjoyed the video and understood it. But please, please, please come with questions ready. And remember that most of this should have been a review from like 5th, 6th, and then mostly 7th grade math. So just, anything you don't understand, highlight or circle, and we'll make sure we go over it with you. See you guys soon.